Hello Matrix, welcome to yet another video, and if you're new, welcome to the channel, and hopefully you'll find something that is user friendly to help you achieve the best of your results. This video was by request by one of you guys, so I hope this finds you still within time during your preparation for your finals. If you're writing the upgrades this May, June, or you are going to be looking at your term 2 exams very soon. So I took this from the Eastern Cape. That was written in September 2021. I've done a functions video on this paper, so I will link that video on the description if you be interested in it, because here we're not going to be doing the functions that I have already done. All right. So let's see, what are the instructions saying? Well, if necessary, we are to do to 2 decimal places. Now this one dictates, it doesn't say minimum or whatever. It says 2 decimal places or not at all, okay? So that is the most important. And then of course, you already know here, if you use a formula, you will have to use, you have to show all the substitutions, the calculations, diagrams, etc. that you've used to determine your answers. It has to be seen. You can't just show up with an answer. Otherwise, the rest is just as usual. So question 1 says, solve for x. Always here we're solving for x. That's what we always do. Okay, so these are quadratics of different kinds all the way, okay? Question 1 is essentially quadratic equations. Now let's start with the standard grade 10 quadratic equation, which is 1.1. So you see that is grade 10 because at that time you haven't heard about the general quadratic formula. So this is basically stuff that's from grade 10. If you think about it. So there's always a representative of grade 10, okay? So it's amazing how these things are the way they are. Anyway, let's move on. So we've got here 1.1, where we've got 1.1.1. So x squared plus 2x minus 15 is equal to 0. Okay, just make sure you've copied it correctly. And then now to solve for x here, the simplest is just to factorize this thing, which is again a grade 10 thing. You learn to factorize in grade 10. So this is x, this is x. Factors of 15 that can give us a 2. It's a 5 and a 3, right? Right, so this is going to be a 5 and a 3. But now the 5 must carry the sign of the middle term. And then that one will help us get to the original. So once you've gotten to this stage, you know that each bracket is equal to 0. So effectively x is minus 5 or x is equal to 3. All right, so those are the solutions. And then of course, when the question is this easy, you may think you're getting away, but you just might not. So be very careful of assuming that these are correct. You can make a mistake of a sign here, so just throw them back into the original and see if you're getting a 0. And then of course, if you get a 0 on the left hand side, to balance the 0 on the right hand side, when you throw these in the spaces for x, then you know those solutions are correct. So how many marks were we scoring here? 3. So they were generous. So factorizing and getting to that level is good. All right, great stuff. So let's go on 1.1.2. So what do we have here? 3x squared plus x minus 1 is equal to 0. And then, of course, we are told to correct to 2 decimal places, which is already something that we are familiar with. So this implies, now we know we're going to use the general quadratic formula here. X is equal to minus b plus or minus. Then we do the general quadratic formula, b squared minus 4ac all over 2a. All right. So that is the story. So now what do we know? We know that the coefficient of x squared together with the sign gives us a. Okay? And then we also know that the coefficient of x, so it's an invisible plus 1, right? Which we don't really write. So that gives us the b. Okay? And then the c is the constant term. So you already know where these things are. So we're going to have 1 minus into 1 plus or minus the square root. We put 1 here squared minus 4 into 3 into minus 1. And then we've got 2 into 3. So we can make our conclusion here. Say therefore x will be equal to, now let's get to the calculator. So we've got minus into 1 plus the square root of 1 squared minus 4 into 3 into minus 1. I'll divide by 2 into 3. So what I'm getting here is a 0, comma, so to 2 decimal places is 4, 3, okay? Or x is going to be equal to, we just go back and change the sign. And then what happens when we change the sign, we get a minus 0, comma, 7, 7, okay? To 2 decimal places. Again, throw this in back into the original form equation. If you get something rounded off to the nearest that is 0, then you know those answers are correct. So don't assume that because you put them into the formula everything is mpashasha. Things do go wrong, okay? Things do go wrong and you end up embarrassed by losing unnecessary marks. But again, this is how you go. Wait, not the formula, but usually the substitution and the 2 solutions is how you get those marks. Okay, let's move on to 1.1.3. So 1.1.3 is x into x minus 3. X into x minus 3 is greater than or equal to minus 2, right? Great. So every time make sure you've copied this right. So what do? We FOIL it out. It becomes x squared minus 3x. We transpose the 2, it becomes a plus 2 greater than or equal to 0. Always make sure you isolate the 0 and the quadratic. Then we can factorize. That's grade 10 stuff, which you should already be comfortable doing. So this is x and x. Then this is going to be minus 2. This is going to be minus 1. No. No, 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 no. Yes, 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 yes. Sometimes the brain just plays tricks on you. But now here there is a bit of a situation. You know that this becomes a critical values. But if you look here, you will notice that the coefficient of x squared is positive. So what does that mean? It means our graph is a smiling parabola, right? 2, the y-intercept is positive. And again, the turning point, if this is minus, remember the x-coordinate is going to be minus b over 2a. This already makes it positive. So we know that if we sketch a graph that is almost accurate, now it's slanting. Yeah, this thing, it doesn't look exactly vertical. So before it drives me crazy, I'm gonna lose my head now. And then we already know here that, okay, all right, we've got our parabola doing things like this here, because we can see that, so it's doing stuff like that. Of course, you don't have to make it accurate, but I'm obsessed with things being, a representation of what I have, rather than to just do a proper rough sketch. But if you believe in rough sketches, it's okay. So the intercepts is what would be the x-intercepts of that parabola, which in this case you call them critical values. So this is 1 and this is 2. And you can see the turning point is positive, because that negative in the middle term already tells us our turning point should be on the positive. Okay, so this is the sketch of our graph. And then of course we know that the y-intercept would have been a 2. But you don't really have to show it in this case. So now what are we looking for? We're looking for x values where this is either at 0 or greater than 0. So what is happening? This is happening here and all the way. Okay? And then it's happening here and all the way. As you can see, the graph is positive on either side of these two critical values, and it is 0 at exactly those critical values. So how do we answer this one? We can say, therefore, our x should be less than or equal to 1, or our x should be greater than or equal to 2. Of course, there's plenty of ways. You can use a simple number line instead of the drawing, but the drawing makes more sense. But a number line will cause you to test a lot of values before you can be sure. And then of course you've got the algebraic table, which also assists in ensuring that you get all your marks. Again, there's plenty of ways you can write this answer, but let's just keep it to a simple thing now, because we don't want to create unnecessary problems. So technically you always get a mark for the tool that you chose. Remember, they said sketch, graph, whatever table that you used to determine your answers, you show it, and then those are the answers. And then the most important part here is this stage here of factorizations, or you can say of making that quadratic. It depends on how you want to see it. Usually this is 4 marks, and it is indeed. So this is how you score those 4 marks. And let's move on. So we've got 1.1.4. So 1.1.4. So we've got this quadratic in third form. So this is root of 43 minus x. I want to do the things. Root of 43 minus x, then minus x plus 1 is equal to 0. Alright, so this is what we have to solve. So make sure you've copied everything correctly. Now the next step here is to isolate the third. No. So the set is root of 43 minus x equals, it's going to be x minus 1. Now, that we've isolated our set, what we do, we just square both sides, because to undo the square root sign, we have to do inverse operations. Now what happens here? It becomes a 43 minus x. Remember, whether it was a plus or minus, because of the square root, it remains positive, okay? So don't find yourself writing a plus and minus on that side. Here you just FOIL out this quadratic, x squared minus 2x plus 1. Easy. And then we move on. Now we can transpose this to the other side and rearrange. So this becomes essentially x squared. When we bring in this one, it becomes minus x. And then now 43 to the other side is minus 43. So we get a minus 42 equals 0. Okay? And then we can factorize this thing. Great and stuff. Almost always will work. So x. Now, what are the factors that give us 42? I think it's a 6 by 7. 6 by 7 is 42, yes. So what are we going to have here? Well, we're going to have 7 and 6, okay? 7 must be negative, 6 must be positive. Great. So therefore our x is equal to minus 6, or our x is equal to 7. Now you take these values, you throw them back into the original and see if you're going to get 0 equal to 0. So let's say, for example, we put a minus 6 there. So this is going to be the square root of 43 plus 6, okay? That is 7. And then 7 plus 6 is 13, plus 1 is 14. So 14 is not equal to 0. So the left-hand side is not equal to the right-hand side when we put a minus 6. As much as we're not getting a negative under the square root sign, but it doesn't satisfy our equation fully. So let's put a 7 here. 43 minus 7 is what? Is what? Is it 36? 43 minus 7. Yeah, it's 36. So square root of 36 is 6. And then 6 minus 7 is minus 1. Minus 1 plus 1 is 0. So this one is correct. Of course, you will just say this one is not applicable. Rejecting it is still a mark, okay? And then your inverse operations somehow took you to this quadratic. So factorizing it and getting those solutions is important. So how many marks are these? Is this question? It's 5 marks, okay? So we've got 3 marks already. I do believe what we've done here is important. That gives us the 4th mark and literally working out our quadratic. So a lot of marks usually on this one. So this one carries a lot of marks and it's the easiest, by the way. So you know. So there we are. There we are. So let's go on. Solve simultaneously for x and y. So simultaneous equations is always there. So let's look into 1.2. So what is the story there? We've got 2y minus x equals 3. Was it minus 3 or is it just 3? Yeah. And then if we sort it out, we can see that if we make x the subject of the formula, it means x is going to be 2y minus 3. And then we can make this one equation 1. Okay? And then we are also given another equation, which is y squared plus 3x is equal to 2xy. Alright, just make sure you've copied everything correctly. Forgive me for this back and forth. It is nothing I can control. Alright, now that we've got these ones, we just simply put 1 in 2, such that we've got y squared plus 3. Now instead of x, we're going to put 2y minus 3 is equal to 2. Instead of x, we're going to put 2y minus 3, and that multiplied by y, which implies that we've got y squared plus 6y minus 9 equals 4y squared minus 6y. Okay, great. So we can transpose everything on the left to the right and still rearrange. So what we're going to get here is 3y squared, and then what happens here? So we're going to have minus 12y, yeah, and then plus 9 is equal to 0. And then this still divides by 3. So this is going to be y squared minus 4y plus 3 equal to 0. Okay, now this implies we can factorize grade 10 style. What is the story? Y minus 3 minus 1. And therefore, y is equal to 1 or y is equal to 3. So a very easy calculation. And then this also may conclude for us that x is going to be 2 into 1 minus 3, or x is equal to 2 into 3 minus 3. Right. So when we sort this one out, it's minus 1. We sort this one out, it's just 3. Again, make a habit of checking these values. Take this together with the corresponding y value. Substitute into any of the original equations. If you get the right-hand side equaling the left-hand side, then you know the work is clean. Again, this is an easy thing to mess up because there's a lot going on. So a sign can be the sabotage here. A digit can be a sabotage. That's why you always want to make sure you double check, because these are easy marks to get. Okay? Very easy marks. Alright. Now I think getting this into this format is important. Substituting one into the other is important. These y values are important, and the x values. So normally you would get something around 6 marks here, but sometimes they make it 5, so they made it 5 marks here. So if it is 5 marks, it means you're not getting a mark for this transformation. You're getting a mark of substituting one into the other and the actual values. So that's how we go. Okay, let's get to 1.3. It says now the roots of a quadratic equation are given as follows. X equals 5 plus or minus the square root of p into 6 minus p minus 9 over 2. But now what is of note is that the discriminant is what is under the square root sign. And we know that the nature of the roots have a heavy bearing on the discriminant. So all we are going to be doing it. Once you hear the word roots, you know that we're dealing with nature of the roots. Grade 11 work here. So it says determine the value or values of p for which the equation will have non-real roots. Okay, so this is easy. We know that for non-real roots, what do we know? It is such that the discriminant delta should be less than or equal to 0. No, not equal to, but less than 0. So when the discriminant is less than 0, meaning what is under the square root sign is negative, you know that is undefined. That's what we mean by non-real roots. Okay? This implies that now here you can decide to write it b squared minus 4ac is less than 0, which you can substitute now. We've got p into 6 minus p minus 9. This is less than 0. That's what we're saying. That expression under the square root sign should be less than 0 for this to have non-real roots. Then when we FOIL it out, what do we get? We get 6p, okay, minus p squared minus 9 less than 0. And then of course the one thing you want to do here, because you can see it's a quadratic that needs factorization, you can just multiply by a negative. Then we will end up with p squared minus 6p plus 9 less than 0. By the way, the sign changes when you multiply by negative. So multiplying or dividing by negative changes the inequality. Okay, so this implies, now let's sort it out. This we can attempt to factorize, right? Right. Which is grade 10 stuff. So this is p, this is p. Now factors of 9 is just going to be minus 3, minus 3. All right? Right. Now the question is, how then do you go about solving this issue? Same way as you do the issue above. Okay, so let's just use something different just for fun. So we're going to take our binomial factors and say p minus 3, but I mean this is p minus 3 all squared, so which is p minus 3. I'm just giving you a taste of a few methods that you can use to solve this matter. So okay, let's see, this is the product. Now if we solve, this is going to be 3 basically. P is just 3, so we don't have the other one. So we may as well just take down this one because it doesn't help. Now when P is 3, we get 0, right? So we've got zeros here for each binomial factor. Then when we use a number less than 0, say minus 1, this one becomes a negative. Then when you use a number greater than 3, this becomes a positive. And this happens for both, okay? Because they are exactly equal. Then now let's do the product. Negative times negative is a positive. This is 0. This one is a positive. So literally, this thing is on either side of 3. So we are not including the 0. So what do we say? We can say therefore P should either be less than 3 or P must be greater than 3. Alright, so this is great. That's how you write it. Of course, there's plenty of notations. if you have been watching my channel for some time, I've tried in many videos to show you all those notations. Just look for any one of my other videos except this one. You'll see that I almost always, continuously tried to showcase every single possible tool that you can use to answer these problems. Anyway, so you're getting 4 marks for this one. Obviously, I think substituting into some correct idea is important. And your chosen tool is important. And then each one of those values make up the 4 marks. That is how you go about your business and you scope your 20. 24 marks. Please try to keep question 1 to a minimum of 30 minutes. Okay? Minimum of 30 minutes. I would say minimum, not maximum, because it depends on how much challenging those questions are. At times they can drag you a bit. But your 30 minutes should be your target line. Alright? Anyway, let's get to question 2. Sequences and series. So easy stuff. Nothing major here. This is something that is too easy. But you guys managed to mess it up. So we are told here this is a quadratic number pattern. So this is easy. Grade 11 stuff as well. So it says write down the next term of the pattern. So 2.1. Then we've got 2.1.1. Now, before we write 2.1.1, let's just be smart about our business here. We've got minus 16, going to minus 12, going to minus 4, and then we're going and going until whenever Jesus comes back. And then of course between these two we know that there's going to be 0. Between these two there's going to be 4. Between these two there's going to be 8. Okay? Great. So between these two there's going to be 4. No, positive 4. And between these two there's going to be 4 as well. And then if you noticed, when you add these ones up, so when we add those, once we add those ones, they give us the next term. Okay? So let's do it. So this is basically 12. Okay? It's going to be 12. All right. No, it's a lie. It's going to be 8. It's going to be 8 because the 4s cancel out. And they leave 8. So we can answer 2.1.1. How many times? 1, 2, 3, 4. So we can just say T5 is equal to 8. Easy. So all you do here, you just add all these up in that diagonal manner. They should give you the things you're looking for. So let's go on. It says now determine the general term. So this question is forever present. So 2.1.2. We know here that this portion here represents 2a. Okay? And then this portion right here represents 3a plus b in general. And then that little friend of ours represents here A plus B plus C. So we know that 2A is equal to 4. Therefore, our A is going to be a 2. This will imply that 3 into 2 plus B is going to be equal to 0. Therefore, our B is basically minus 6. Okay? And then, which also implies that 2 minus 6 plus C should be equal to minus 16. Therefore, C is going to be equal to, did I write B here? Should not, yeah, that's a 6 anyway. So that's a 4, right? So this is, let me see now. Yeah, this is going to be minus 4. When it comes here, it's going to be a plus 4. So minus 16 plus 4, it's going to be minus 12, okay? So we can conclude that our nth term is going to be 2n squared minus 6n minus 12. Now let's check it out. If we put 1, for example, this is just going to be 2 minus 6, which is minus 4. Minus 4 minus 12 is minus 16. Of course, there are coincidences. Check others that are not contiguous to this term you checked, meaning skip a term in between. If your formula still holds true, it simply means you are correct. Chances of being wrong are small. So finding A, finding B, finding C, and how you put it at the end is how you got those 4 marks. It says now calculate the 38th term of the pattern. Okay, 2.1.3. We know that Tn is equal to 2n squared minus 6n minus 12. This implies that T38 is going to be 2 into 38 squared minus 6 into 38 minus 12. And let's get the answer there. 2 into 38 squared minus 6 into 38 minus 12. This is 2, 6, 4, 8, okay? This one, you don't really have much of a choice, but to just make sure you substituted correctly. Because if you don't, it's going to be a problem. It's going to be a problem. Alright, so what do you do here? Usually 2 marks, correct substitution and the answer. But at times they can give you just 1 mark. They can be that cruel. Sometimes they are not very lovely. Okay, it says now determine which 2 consecutive terms of the pattern will have a difference of 400. Okay, so the easiest way to answer this question, I think it's been asked multiple times. So the easiest way is to use the sequence of the first differences. It's always easier when you go about it that way. The other way can be a little bit silly, but I'll show you how it's done. Anyway, this is 2.1.4. So we know that, well, they are telling us that if we're looking at the first differences, they are giving us the fact that A plus n minus 1 into D is equal to 400. You can choose how you want to go about it. That was a 0. That's what we want. The common difference there was a 4, right? So that is the situation right there. And then we sort it out. We can see that 4n minus 4 is going to be equal to 400. which also implies that 4n is going to be 404. Therefore, our n is when we divide throughout by 4. So let's see, 404 divided by 4, it's 101. So look, always the position of this first difference right here in the sequence of the first differences always coincides with the same number that made it up. I don't know if I'm making sense. This number, the position of this number in the sequence of the first differences will always coincide with the position of the lower term of the two that made it up. Okay, so we can say therefore 400 is the difference between t. I always choose the one ahead, 102. It's always going to be just one digit ahead, and t 101. So this is how easy you can answer this question. And then of course there's plenty of other ways you can look at it, but at times you just want the simplest route, because others, they are nice, they're a bit concise, but they will hurt you a little bit. But either way, we just go on and on and on and on. So some people would prefer something like this. I'm just going to show you, I'm not going to solve. Some people would prefer to say we want the term ahead. Remember, Tn is the nth term. The next term there is going to be Tn plus 1 minus Tn will give us 400. Okay, so if you do it like that, you are sorted, right? Because all you do, you just simply substitute n minus 1 into that nth term formula. So you're going to have 2 into n plus 1, and then squared minus 6 into n plus 1 minus 12 minus Tn itself is 2n squared minus 6n minus 12 equals 400. Okay, then continue to solve here. Solve further. You will see you'll come to the same answer that we got, which is 101. Then you just simply think of the term ahead. Because if Tn is 101, then plus 1 is going to be 102. So you will still get the same thing. So it's just how you start that matters. But whichever start you choose, it should give you all the answers that you need. Anyway, let's go on, guys. How many marks were we scoring here? Oops, we're just scoring 3 marks. Okay, so I guess. But I think here, I don't know, man. Yeah, whatever. But I do believe this would be 1 mark. The conclusion, at least that substitution should give you something of those 3 marks. All right, that's it. Let's get to question 2.2. Now 2.2 says, given the arithmetic series 2 plus 5 plus 8 plus 89. So can you see 89 is the last term, because the equal sign means the sum. So it means the sum of this series is k, all right? But the last term of this sequence or series is 89. And the first term is 2. All right? So these are some of the things you want to make sure you are clear about, because if you're not, they're going to hurt you. It says now determine the number of terms in this series. Well, if this is an arithmetic, already we don't need to check between any 2 consecutive terms. So we just take, in fact, we do need to just consider one set of consecutive terms take the difference, it should give us the common difference, because this is an arithmetic sequence, so we don't need to worry about it. So we want to start with D. It's going to be 5 minus 2, which is 3, but we can even see it by inspection. Sometimes you may even just write D is equal to 3, because this is too easy. You don't need to be showing the calculation. You are grade 12. Then we know that, well, Tn is equal to A plus n minus 1 into D, right? Right. But now we know that the last term is 89. The first term was a 5. Was it a 5? 2. Plus n minus 1. The common difference is a 3. We work it out. 89 equals 2 plus 3n minus 3. This implies that 3n is equal to, now this becomes 90. Okay? Therefore, our n, when we divide by 3, is 30. So there are 30 terms here in this sequence. So easy stuff. As you can see, you're just only getting 2 marks, which I believe is just the correct substitution and the answer, because this, by inspection, you could find it. Okay? All right, let's go. It says determine the value of k. So now we want the sum of those 30 terms. Easy stuff. So we've got 2.2.2. So we know that Sn, let's just do it this way. We know that k is equal to Sn, which is basically going to be, sometimes I don't like to drag, it's going to be n over 2 into a plus l, because we don't know, we do know the last term. So n is 30 over 2. This is 2 plus 89. Okay, great. So when this one is that easy, don't sweat. So we've got 15 into 2 plus 89. So I'm getting 1, 3, 6, 5. Great stuff. So that is easy. Again, 3 marks. Okay. So not a problem. So you're getting that, and most likely that statement or this formula, whatever. That is it. So this is how you get those 15 marks. See, some questions can be pretty easy to go around, but others can be a bit of a situation. Again, this is still sequences and series. So you'll always get all 3: arithmetic, geometric, quadratic, and you'll get the sum to infinity. So there's no way you're going to escape those ones. You need to know all. And please know their applications. They can surprise you. Okay? If you watch a video on the prelims from Gauteng that I did, you will see that the question on optimization, or should we say application of differential calculus, you will see there that there is a direct application of sequences and series there. And usually that's what helps you to crack that problem, because it looked unassailable at first. But the more you think about these things holistically instead of in isolation, and you start to just thrive, no matter how difficult the situation looks. And in fact, you look at people and smile when they're saying this was hard. You're like, you don't know your work. Anyway, let's go on. Given that in geometric sequence, okay, we've got a geometric sequence. T9 is 7, 6, 8. Okay. Okay. So what does that mean? This implies that T9 is always going to be a r to the 8 is equal to 768. We can make this one equation 1. Okay. Next equation. They're telling us that T13 is 12,288. So we know that T13 is 12,288. So what does this imply? This implies that we've got AR to the 12 is equal to 12,008 I1. Okay, so that's what we've got. Now we can play a smart mathematical game here and say, look, we can decide to split this A into R to the 8 times R to the 4 is equal to 12,288, isn't it? Because these R's, when you combine them, they'll still give you AR12. So just playing a mathematical game, because what we're interested in, we want to substitute this with a number instead of having a very long and nasty calculation. So integration, guys, you need to know how to integrate information. So what do we know? AR to the exponent 8 is basically 768. So this is 768. R to the exponent 4 is 12,288. And then, of course, we divide by 768. So we get R to the 4 is equal to, so let's do that one. 12,288 divided by 768. It's 16. Okay. And then what do? We can take the fourth root of each if we like, but I like to use exponents. But the problem of using exponents is that you're going to lose greatly. So let's not be careless. What were we doing, by the way? Determine the value or values. See, once they do that, of the common ratio and the first term of the sequence. Now, you know, here you may run into some problems if you're not careful, because they're saying value or values. So if you go the exponential route, you'll run into issues because you'll only get one answer. What if there are two? So the best is to take the fourth root here. Okay, so that means our R remember, once you take an even root, it becomes a plus and a minus. Okay, always an even root is always going to give us that. So let's do it. Let's take the fourth root of 16. Of course, you know it's a 2, right? So it's going to be plus or minus 2. So those are the values of R. Therefore, we know that our A is going to be equal to, let's think about it. This will imply that AR8, so we know that A, instead of R, you can put a plus or minus 2 to the exponent 8 is equal to, we found out that it was 768. So I'm putting the values of R into equation 1. So therefore our A is going to be, remember, even if it's negative or positive, if you are raising it by some even square, or what can you say, you're raising it to an even exponent. Okay, let's put it that way instead of talking nonsense. So if you're raising any number, negative or positive, by an even exponent, it will always come out positive. Okay, so basically here we've got here 768 divided by 2 to the exponent 8. Okay, and then that gives me a 3. All right. So that is the story. So it's very important, and that is an answer on its own. Okay, great. So how many marks were we trying to score here? Just 3 marks. Are you serious? Anyhow, I would say here substituting one into the other, or this gymnastic in a way, is important, and those 2 values are important, and the a value is important. Or you may get 2 marks for the answer here, and then 1 mark for this one. The rest is something you are expected to know. Okay, now we are told here the sum to infinity of a convergent geometric series is 54/19. The sum to infinity of the same series calculated from the third term is 24/19. So it says here, calculate the sum of the first 2 terms of the series. Okay. Now let's think about this one just right. We've got to think about this one just right. So 3.2. Then we've got 3.2.1. Will you believe me when I say the S2 here is going to be the sum to infinity of all those terms minus the sum to infinity from the third. Right? Think about it. Let's assume this sequence was 1 plus 2 plus 3 plus 4 plus 5. 5 being infinity, if you think about it. All right? Great. And then we are starting from the third in the second instance, 4 plus 5. 5 being infinity as well. So do you see what happens here? What happens? What would be the sum of the first 2 terms here? It will be this, right? It's going to be 3. Isn't it? Because all these terms cancel. Right? If we are only looking for the sum of the first 2 terms. So we'll just take that one and subtract this one. These terms subtract, and we're left with that. So this is why that thing will work. Okay? This is why that thing will work. And then of course, if you did not cancel these terms, you could easily just find the sum here. This would be 15. And then this one would be 7 plus 5 is 12. So do you see here? This one minus that is basically 3. But what is 1 plus 2 is 3. So do you see? It works out. So sometimes you've got to find a way of explaining things to yourself because they may not really be clear. Because remember, this thing is a mental challenge. It's not about trying to give you easy marks, but the idea is just to challenge your brain a little bit. So that is the story right there. So what was the sum to infinity? There's 54/19 minus the other one from the third is 24/19. So this is the same as just over 19 because that's the common denominator. 54 minus 24, I think is 32. 54 minus 24 is 30. Okay, it's 30, not 32. I overly estimated. So that's it. That's it. How many marks were you supposed to score there? Just 1 mark. Okay. So remember, when something doesn't make sense, try to do something parallel to it that will help you to understand what's going on. And then you sort it out. and then you sort it out. All right. Now 3.2.2, it says show that a is equal to that expression. Okay, that's easy. 3.2.2. So what are we going to do? Well, we know that, remember this is a geometric series, so we know that a plus AR, which is the second term. Remember, this is the first, this would be the second term, should give us 30/19 from above. Okay? So when you factor out A here by factorization, it's going to be 1 plus R equals 30/19. Okay? So therefore, when you divide by this one here, we know that A is going to be 30/19 divided by 1 plus R, which is itself over 1. And when you flip this, what happens? We get 30/19 into, because this becomes now in the denominator. I'm not happy with my 19. So this one is going to be 1 plus R. Okay, so that's done. Straightforward. So you see, this was effectively S2, if you remember from above. And in general, that's how you could write it. So the S2 in 3.2.1 is what you're going to use to get to this one. And this, in a way, confirms that that answer you got was correct. Okay, easy stuff. We've done it. No manga business there. So you are getting just 1 mark again. Wow. Anyway, so for me, I would suppose that step is the most important, therefore. Or you can mark yourself there. It doesn't really matter. The rest is maths, which you should already know. Anyway, let's move on. Now it says determine the value of R. If R is greater than 0. So you see they're giving us the condition because they are away. We might find ourselves with values of R that are a bit many, then we need to make a selection. So this is 3.2. Okay, now let's see, 3.2.3, man. Did I write that? Okay, yes. So now let's think about it. What do we want, folks? We want to solve for the value of R. Okay. Easy. So what do we know? What equation do we know here? Well, we know 2 equations. We know that the first term, we know that the sum to infinity was 54/19. We can use that one and say, well, we know that the sum to infinity was 54/19. That was given. All right. Now, what do we know about sum to infinity? We know that it's A over 1 minus R equals 54/19. Now, what do we know? We know that our A is 30/19 into 1 plus R. Okay? That's our A right there. And then we are going to say we are dividing this by 1 minus R. Okay? Equals 54/19. I'm trying to think what was the best way that I should have done this. The best way to have done this mess anyway, this is easy. It's easy. Let's just go for it. So this is 30/19 into 1 plus r. Now when you change this to multiplication, it becomes 1 over 1 minus r equals 54 over 19. Great, I'm just trying to show you the math, otherwise you could easily skip some steps here if you already know what's going on. So this is going to be 30 over 19 into 1 plus r into 1 minus r equals 54 over 19. So at this point, it helps to cross multiply something, to always deal with problems effectively. Now you've got two options here. You can just cross multiply this one alone into there, right? To try and make your life a lot easier. I mean, cross multiplication, not forced to do this one as well. When you know maths, you know that you can just do one if you like for convenience. So this will tell me that 30 is equal to, remember once you multiply that one here, the 19s will cancel. So we're only going to get 54 into 1 plus r into 1 minus r. You divide by 54 as well. So we've got 30 over 54 is equal to, we FOIL this thing out, it's going to be 1 minus r squared. It's a difference of 2 squares, isn't it? Yebo. Yes. And then what do we do now? We take this one there. This implies that r squared is equal to 30 over, it's going to be 1 minus 30 over 54. Okay, that's what this is going to be. Let's sort it out. 54 minus 30 is 32, right? 34. Wait a minute. 54 minus 30 is what? It didn't go down for the spot. Please, my brain, don't do this to me, huh? 54 minus 30. I angisakhumbuli bafethu khathi sibone 54 minus 30 is 24 mas. Yeah, doch, it's 24 over 54. Okay, which will also simplify into 4 over 9. Okay, 12 goes. Wait a minute, what goes 4 times to 24? Huh? What is it? Is it 6? Yes, 6 goes 4 times. 6 to 54 goes 9 times. Yeah. And then, look, this is r squared. Okay, I don't know why I had to take so long to do this, but yeah, I did anyway. At this point, for me, once they're telling me that r is greater than 0, I can use exponents, all right? Exponents tell me that r squared is going to be equal to 2 over 3 squared. Once you've got powers with the same exponents, you equate the bases. R is going to be 3 over 2, which is positive. Okay? I don't know why I dragged, but yeah, I did. It's fine. Just so you can see a bit of maths at play. But if they didn't tell you what was the value of r, so you see the method when you get to the stage can differ depending on the intention. If they didn't tell you what r is like, the safest is to say r squared equals 4 over 9. You take the square root. Therefore, your r is going to be a plus or minus 3 over 2. No, I'm lying. It's 2 over 3. So So like you see how mistakes come in easily. So you see, if they said it's negative, then you know it comes out nicely. But all I can tell you is, even if you use the exponential rules, once you have even exponents, just know the value inside here should be a plus and a minus because of the square. Or should we say an even exponent? So whenever you have an even exponent, even if you didn't want to use this thing, grade 9 style of just taking the square root, you just know that once you have an even exponent, depending on the question, you want to consider plus and minus values, because either way, whether it's negative or positive, it comes out positive because of an even exponent. Anyway, that's how you do it, guys. So that is the value of r. Easy stuff. So a little bit of mathematical gymnastics had to be employed. So this part right here is important. Yeah, I think this method is important. So there's the 4 marks. Is it 1, 2, 3? Where's the 4th mark? Can go. Doesn't matter, guys. It belongs wherever it belongs, okay? It belongs wherever it belongs. There's a lot of gymnastics that don't matter here. I don't know, man. I don't know. So a lot of things can be a bit of a situation. Sometimes you can get a mark there. I don't know where's the 4th mark. Either way, let's move on. So I've done functions on another video, so please don't be looking for them. They are not here, okay? So now we're going to jump into financial maths. All right, so question 6 is financial maths. So by the way, I will try to link that video on the description, so please do check the description box of this video so that you can find a link to the function section of this paper, if you'd be interested in it, of course. Now let's do the money. The thing that makes people do things that are not supposed to be done, especially by people of their caliber. But yeah, people are losing themselves in the quest for easy money, eh? Let's just do it. Let's do some damage. It's the easiest thing you can do. It says now Ellie bought a laptop 4 years ago. So they're telling us the time frame. The value of the laptop depreciates from, now we can see that it came from this big amount right here, on a reducing balance. So again, we're being told what method is employed here. So here, this question was made too simple. It was made too simple. Siempre. Now, balance method to its current value of 5,509 rands 70 cents. Now it says calculate the annual rate of depreciation of this laptop. Easy stuff. So 6.1. What do we know? We know that A equals P into 1 minus R to the n. That is the reducing balance formula. Great. And now this one, we were told that it does this annually, meaning yearly. So what does this imply? That was it reduced to 5,509.70. So this is 5,509.70 equals, the first one was 9,670. Actually, we don't need the commas there. 9,670 into 1 minus R, which is what we want. But now it was a period of 4 years. So that is it. So you know the quickest thing here to do is to essentially divide by this one. So we're going to 550970 divide by 9670 is equal to 1 minus r to the 4. Okay, now what you do at this point, you take the fourth root. You always do an inverse operation here, because what you do on the right hand side you must do on the left hand side. Okay, easy stuff. So now all we know is that on this side we're going to have 1 minus r. That's what we're going to have. But now let's deal with that other part now, which is 550970 divided by 9670. This one gives us a 0. Oops, no, I took a square root. I want the fourth root. Hey, so sometimes be careful, guys, of how you calculate these things. It's easy to make mistakes. But you won't be like me. You won't be talking to anybody, so most likely you will maintain the focus. But when you're teaching somebody, it's easy to lose that focus, because what makes you unaware of what you're doing is because you are talking. So when you're not talking to anybody, that's already a protection from this issue I'm having here. Okay, so you write everything as it appears, okay? You don't round off. Then this implies, you can tell that r will go that way. This is going to be 1 minus 0.8688111174. Okay, so this becomes 0.1313. What are you doing? 3, 1, then maybe let's make it 2, because 4 decimal places already will sort us out, because we'll have 2 decimal places, which is the required thing. And then here, did I say r? No, man, we don't use r here, we use I. Okay, so I'm doing my own things now, and you guys are quiet. Litla shwabana ba ga le sa bui fela o sa no ngakhale fele mbelekweni seniyazi ke lonto nizeke nje niyazi ke liyonto. So we can say therefore you can just multiply this thing by 100. This is going to be 13.12%. You can use it as percentage, but you can leave it as that one on top. But what makes sense is percentage. So normally, I think your exam guidelines, whatever, will tell you exactly what is the acceptable answer. But I think in percentage form is what makes a lot more sense than the other one. Great, easy stuff, guys. So this one is a nice question. Nothing really serious. So correct substitution, answer, and of course that inverse operation technique is important. Okay, let's get to 6.2. So 6.2 says Mr. Duba or Duda, Mr. Duda decided to save money towards his son's tertiary education. Okay, as follows: he paid 600 per month into an account that paid 8.7%. I would love to see such a rate in RSA. It does not seem to exist. It does not seem to exist. This country is an absolute rip-off. I'm telling you. You put money, you don't get anything back. But you borrow money, you pay everything back. How sad. Anyway, it's fine. Maybe we should learn to never use the stupid banks anyway. You should go back to the paycheck. But again, they'll charge you when you change it. So what can we say? Pay in cash, okay? Yeah, I think if they were to pay us in cash, it would be better. We just have to own guns. When criminals come, we shoot them. That's it. But anyway, it's fine, man. We will never win that war. You see, the propaganda has become so great that nobody can actually deal with it. You either join it and enjoy the spoils of the crap, or you sit on the sidelines watching things happen. You're gaining nothing, or you get involved, you get ripped off, and you cry. So, yeah, doch. Money matters. No one can ever solve them except those who make the rules. All right, let's go on. So Mr. Duda decided to save money towards his son's tertiary education, okay? He paid 600 per month into an account that paid a rate of 8.7%, which is definitely, if you can get this in South Africa, you are the luckiest, because it's running around 2%. Standard Bank, I think it's around there. It's ridiculous. And then if you are lucky, go to the likes of Capitec and stuff. Maybe you might see some 5% if you're lucky. Yeah. But 8, I'm yet to see it. Okay, it's compounded monthly. So again, look at how it is compounded. It's important. Now his first payment was made at the end of January, in which his son started grade 1. And the last payment was made at the end of December, when his son completed grade 12. Okay? His son did not repeat any grade, so he was a genius, eh? Somebody worth keeping the money for, not the ones who just fall into the cracks of this world. Anyway, so Mr. Duda is a lucky man to have a brilliant son. Now he withdrew his all his savings 1 month after his last payment. Okay, so that means this thing went on for an extra month. Okay, so you know very well that a child who goes to school from 1 year until grade 12 without failing, that's a period of 12 years. Okay, that's a period of 12 years. So this thing is going to be paying money for 12 years. And then he will take it a month later. He's going to add a month to this. 1 month later, he gets it all, okay? So remember that. That is the most important. So please read, and read. Make sure the English is clear, because if the English is not understood, you will die a slow death, okay? So I don't want you to die. So now it says calculate the amount that was in his account by the time Mr. Duda withdrew the savings, okay? Now what helps us to answer 6.2 is to draw a timeline. Not that it matters, of course, if you already know what to do, folks. If you already know what to do, you don't need to do what I'm doing. For me, it's just a way of making sure that when I get a complicated question, I know what to do. Now we said this is going to go on for 12 years, okay? At first, all right? Okay, all right. So he will be paying money for 12 years. So let's calculate. 12 has 12 months in it. So it's going to be 144, right? It's going to be 12 by 12, which is 144. So this man is going to be paying $600. He's gonna be paying 36, 36. That's it. And then this situation on its own for that same period. Let's just be artistic a little bit, okay? So remember the compounding rates can change. So sometimes you want to make sure that it is stretching throughout. If it is stretching throughout, you will hardly get one that breaks into 2 or 3, but it can happen. Expect it. So this is down monthly. So that was 8.7%. Wow. I would wish to have an account that pays this much. They don't, They don't. Okay, so now that we understand where we are going, this is future value, right? But now remember the question says, we want to know that Mr. Duda will go on to draw this a month later. So he will draw this one a month later. So that is the period over and above. So that means we need to find the future value for these 44 terms. And whatever future value that will be, it will carry through for just 1 month. So meaning we're going to do compound interest on that big lump sum to get the answer right. So do you see when you draw up a timeline, it gives you an understanding of what you are supposed to do, because it's easy to get confused. So let's see. We want the amount of money that this man is going to have. So it's going to be our future value, which is going to be our x into 1 plus I to the n minus 1 over I. But now we also are going to take this future value and multiply it and compound it. So when we compound it, it's going to be like this. But now the period is just 1 month, so it's to the 1. All right, or maybe we can say to the n as well, because it depends on how many n's. But don't confuse that n and this one. They are not the same. All right, so that is the story we're going to have here. So the adaptation here, guys, is this portion here. This is the only new thing here. Be careful of that. Then this is 600 into 1 plus, now this is over 100, so it's going to be 0.087 over 12, because there's 12 months in a year. And then to the exponent 144 minus 1. And then we're going to divide this one by 0.087 all over 12. And then we multiply this thing by 1 plus, this didn't change, 0.087 over 12. This is to the 1 because it's just 1 month extra. Let's do them chinks. What are them chinks that we're getting? So 600 into 1 plus 0.087 over 12 raised to the exponent 144 minus 1, close that damn thing, 0.087 divided by 12. This thing, we are multiplying it by 1 plus 0.087. Sometimes your calculators may start screaming at this point because they will feel like you are punking them a bit, you know. So sometimes it may cry, sometimes it may not cry, but what I'm getting here is 152,536 rands 13 cents. Okay, to two decimal places. So this is the amount of moolah. This is the amount of moolah that this mister is going to be getting. Okay, what is important is just to remember that that lump sum will in its entirety accumulate some interest for just 1 month, of course noting that it has not changed. Okay, all right, okay. So a very simple calculation, no issues about it, 4 marks. Okay, now what matters is to know the terms right there, is it not? And the interest rate is important, and then we can say the general substitution essentially in there. Maybe let's just say here, because this is one and the same thing, and then we're getting you the mark for the answer. So there's a lot of areas, but these are easy questions, guys. Please don't lose marks on financial maths. It's easy. There's nothing difficult. You just need to get the statements that are given, convert them into some mathematical sense. Make sure you thread carefully, that's all. But if you know the timeline, how to do it and to do it properly, you know what formulas are applicable, this thing is easy. It's very easy. Anyway, let's go on. 6.3, we're told Pilisa takes out a loan to buy a car that costs 350 scodos, right? So already starting on a negative. The bank offers her an interest of 9.3% per annum, compounded monthly. Okay, and a payment period of 6 years. So you see, you're told everything. Now his first installment is due at the end of the first month after taking the loan. So obviously that first month, that's what you call a grace period. Sometimes, back in 2012, the grace period when you do car financing or stuff, it used to be around 3 months or so. But I don't know if they were lying to us, telling us that's a grace period, only to find that they are screwing you. They are taking interest out so that you pay more. I mean, we are naive, let's be honest. We did not have so much financial literacy. So it's easy for those people to pretend like they're playing the game in our benefit or in our interest, only to find that they're actually doing it in their own interest. So my best thing for you or anybody else, just choose to pay, just a month after, so that you don't accumulate so much interest. But at the same time, it depends on the period of payment, because you are allowed to choose whatever suits you. And as a result, that may need adjustments. So your grace period may move from just a month to 3 months. Usually it's 3 months if it is longer, but normally it is just 1 month. Okay. Anyhow, let's go on. So it says now, calculate Pilisa's monthly installment. Okay, great. So 6.3, we also need a timeline. But what is different about this timeline? At T0, we took out 350 scodos, right? That's what we borrowed from the bank. And then by the end of the first month, which is T1, we were paying some X amount, okay? And then we continued to pay some X amount. And we continued to pay some X amount. But now what are these terms right here? Well, we were told it's 6 years, so this is monthly, so this is 12 by 6, which is 72. This is 71, okay? And then now this whole business, this whole shenanigan has been happening over 9.3%. So this was per annum, meaning per year, compounded monthly. So now that we have our timeline in order, so let's find out what should Philisa be paying for this period. So this is a present value calculation. So P is equal to X into 1 minus 1 plus I to the N. So now these formulas by heart so that you don't do this back and forth. It has, actually this is to the minus N. Okay? So know these things by heart so that you struggle less. Trust me, when you know them by heart, you'll struggle less. Well. What is important here now is to do the things that must be done. So we know that our thingy here is 350 squares. We want X, 1 minus 1 plus, this is going to be 0.093 over 12. Now to the minus 72. All of it over 0.093 over 12. All right. So now that we've substituted, we can make our nice conclusion. So we're going to perform some serious gymnastics. We take this and multiply it there. So this is 350 squares into 0.093 divided by 12. All of that, we're going to divide it by that major bracket right here. 1 minus 1 plus 0.093 over 12 to the minus 72. Great. So that is how you handle this business. So let's do it. 350 squares into 1 plus 0.093 over 12 divide by 1 minus into 1 plus 0.093 over 12. This one to the exponent minus 72. All right, okay, all right. Hayi, makancinci. Imakancinci itheni yabaninzi kangaka le mali. Why ininzi ngoku? Is there a place where I put some things wrongly? Ayikwazi baninzi kangaka bafowethu. Soze. Itheni yayinqwaba ngo? Hayibo. Ayikwazi bafowethu. Ayikwazi bafowethu. Khona into engekho right. Something is not right. Oh Lord. Yintoni ingxaki yam ke ngoku? Hayi, ndithola imali enkulu kakhulu la. I'm getting a lot of money, and now that worries me. Okay, let's start again. 351 to 3 into 1 plus, oh yeah, I substituted incorrectly this part here, so 0.093 over 12. So there was an incorrect substitution in the numerator, so it explains why there was this little hiccup. So please guys, interrogate your answer that you get, because the answer that you get, if it is outrageous, chances are you are in the wrong. If it is reasonable, like this one now, I'm getting like 6 scored or 33, 61 bucks. Comma 18 cents. So that is a bit fair, because that is outrageous for just 6 years, and it was just 350 scored. Shouldn't be paying more than that for that rate. So be familiar with these rates and what they can do over a period of time. Sometimes be comfortable with some situations, because if you're not, those situations are going to be comfortable with you. And when they start doing you a number or two, you're going to cry. Okay? So let's see, guys. How many marks were we scoring here? I'm feeling a bit slow at the moment. It's just 3 marks. Okay. Easy. Easy, easy. So these marks is this period. It's very important, and this rate is really, really, really important in the answer. Okay. So the rest is expected of you. So sometimes you're not going to get a mark for a proper general substitution, or you can decide that this whole term together with the period is 1 mark and the general substitution is 1 mark. But at times it's very difficult to distribute these marks fairly. The next question says, calculate the balance of her loan after the 40th payment. Okay, so this is essentially the balance outstanding, if you think about it. No. Yes. Yeah. The balance is the balance outstanding. Remember that. So yeah. So this one you have 2 ways to calculate it, but let's just spice it up this time around and do it another way. So that was 6.3.1. Okay guys, ish. Kind of messed up a little bit here. I like things to follow properly. Okay. Yeah, so 6.3.2. We want the balance outstanding. So we know that, well, the balance outstanding, we can use the future value here. Sorry, the present value. The future value one is nasty. I don't like it. It's too long, but I'll show you how it works. So let's use the present value here. This is going to be x into 1 minus 1 plus I to the minus n all over I. So remember, we are still paying that same monthly installment. So we're going to put x as that amount. So this is 6361,18 into 1 minus 1 plus 0,093 over 12 to the minus. Now the question is, what is n? Now n is the difference. This n is going to be the 72nd period minus the 40th, which is going to be 32, right? 72 minus 40. Yes, it's 32. So basically the period remaining is what you're going to put there, because that's what the amount you would be paying should be, isn't it? So now this is going to be minus 32 instead. So the key is this guy. The rest is just simple. So this is 0.093 over 12. So this one is quick. As you can see, it gets to the point much quicker. But you need to be aware that your friend here is something you need to work on. So let's do it. 6361,18 into 1 minus 21 plus 0.093 divided by 12 to the exponent minus 32. We close that one, we divide by 0.093 divided by 12. So with these calculations, usually the problem is the substitutions. They are too complex. They are busy. These are not quiet substitutions. So this is basically 179,667 32 cents. Okay, so that's quite a lot of money. That's quite a lot. I mean, you've made 40 payments, but you're still missing more than half of the amount you took. Yeah, that is the issues of compound interest. Okay guys, that is the story right there. So this one is a simple calculation when you're using the present value formula, but in a smart way. But you can still use balance outstanding. You use the future value minus by the way, what do we subtract? I'm trying to think. What do we do here? Asayikhumbuli ke ngo. Konje use a future value and what? Yabona? Yabona. Uyabona ke. But remember, we're going to use the future value for the entire period. Ne? And we're going to subtract again the future value for the remaining period. You understand me? Then that tells us the balance outstanding. Into ndikhohliwe ke ngokule formula. I forgot it, guys. Check my other videos. It's at some point my brain is fried, okay? But if you wanted to use the future value formula, remember, for us to know how much we are owing is essentially to take the future value of this entire 144, right? And then we subtract the amount that we've already paid, which is up to the 40 terms that we will have paid. Then whatever remains is the balance outstanding. I forgot how I used to write this formula, that's all. But forget it for now, it's not a big deal. Okay? It's not a big deal. So now what you can do, take balance outstanding is going to be the future value of the 144 terms minus the future value of the 40 terms paid. It will give you the balance outstanding. I'll just modify it. Because I can. Sometimes it's nice when you can do things just the way you like it. Let's move on, guys. For me, I always try to make sense of even a senseless situation. Okay, guys, let's move on. Pelisa decides to increase her monthly installment to 7 squad. Okay, after the 40th payment. So now there's a bit of a change. How long after the 40th payment will it take for her to pay up the loan? So they want the period. Okay, That's fine, not a problem. So already we know the balance outstanding, so this question was pretty nice. They could have made it difficult, and never asked us to find out how much was remaining. But now the amount of money she should be paying is this one. So we can still use the present value formula, 63.3. Sorry, we know that the balance outstanding here was given by x into 1 minus 1 plus I to the minus n over I. Okay, that's what we saw. And then we realized that that balance outstanding was 179,667.32 equals, now we want to pay 7,000 instead, into 1 minus 1 plus same interest. But now after the 40th, remember we're going to pay for 32 terms. Okay. All right, so 0,093 divided by 12. Obviously, sorry, we don't know how much. That's what we want. That's minus n, sorry. Okay guys, so the gymnastics are fairly simple here. What you do, you cross multiply that thing there, right? Right. After you've cross multiplied that thing, you divide by 700, right? Right. And then you will take this whole mush from 1, okay? All right. And then you introduce logs. So this log situation, I'm just going to jump into the answer, guys. But anyway, there's a bit of space, but yeah. Let's just do the simplest thing ever. So we know that doing our gymnastics here, essentially n is going to be equal to, maybe let's write it a bit further down. Is going to be minus the log, right, of, now the base, remember the base is going to be this guy, with n left out when using log rules. So the base here is going to be 1 plus 0,093 over 12, okay? And the number on top is going to be 1 minus this thing, 179,667.32 into this interest here, which is 0,093 over 12. Okay, and then this one, we're going to divide it by that 7,000. Okay, so that is the log of this number to this particular base. So let's sort it out. So we've got here minus log. Now the base here is 1 plus 0,093. Like I said, these ones are annoying in that they are complicated. Okay, they are really complicated. 179,667.32 into 0,093 over 12. So here you just guard against mistakes in your substitution. Otherwise, this can be a fairly simple calculation. So what I'm getting here, this is 28, comma, let's say to 2 decimal places is going to be 73, which is approximately 29 terms. Why do I even need those? I've made my conclusion. So essentially, remember that terms of payments cannot be a half term. It has to be a full month. So it's approximately 29. And remember, you are going to pay 32 terms, right? So you're going to use 32 terms after the 40th payment, as you could see here. But now, you will end up paying less, 29 terms instead, if you increased your payment. So it makes sense, is it not? Yeah, it does make sense, guys. So that's it. That's it, folks. That's the end of our financial maths question. So we're getting 4 marks. So they were generous here. They decided to be super generous. So I don't know how those 4 marks come about, guys. It's ridiculous, you know. Correct substitution, obvious. Obvious. Introduction of logs, obvious. The answer, obvious. Yeah, well, maybe we can say if you took this and rounded off to the nearest term. I don't know. These marks can be anywhere. If you've got the drill, you will be able to get your 4 marks. So financial maths, guys, is easy. You just need to be patient. Make sure you're meticulous in your substitutions. Make sure you trace every number and you question the value that you get. Sometimes big values may not really make much of a sense because we don't often deal with these naturally. So it's easy to miss the point if the answer is big enough to confuse you. But at times, you know, doing many examples that will involve these kinds of questions, you'll almost know when something is wrong. There's something called a gut feel. It always tells you when something is not quite. When something is not quite, it always screams. Okay, let's do 7. Differential calculus. I don't know if we did this one in the previous video or not, but let's go for it. Question 7.1. This is now sorting things from the first principles. So what do we know? We know that the f prime of x is equal to the limit as h tends to 0 of Sir Isaac Newton's quotient. So this is f of x plus h minus f of x divided by h. Great. That is as simple as that. And then we start working lim as h tends to 0. Let's substitute. So we've got 5 minus 2 into, now instead of x we're going to put x plus h, and then that is squared. Then that's done. Then we're going to subtract. F of x is basically 5 minus 2x squared. Alright. Okay, alright. So that's it over h. Now let's go for it. This is lim as h tends to 0. Let's deal with this thing. 5 minus 2 into, we sort this one out as x squared plus 2xh plus h squared minus 5 plus 2x squared over h. Okay, and then let's sort this one out. Lim as h tends to 0. Let's just fold this thing properly. Do me a straight line, okay? Now we're going to have 5 minus 2x squared plus 4xh. No, it's minus. So it's minus 4xh minus 2h squared minus 5 plus 2x squared over h. So these friends take care of each other just right. So if nothing takes care of each other, just know you are not doing well. Some things need to fall off. Okay, so we've got ourselves here minus 4xh minus 2h squared over h, which is going to be lim h tends to 0. So here we take out the highest common factor. It's going to be basically h. In fact, we take the lowest here. The lowest is the lowest common factor, by the way. It's going to be h into minus 4x minus 2h divided by h. And then these guys finally do it. After waiting for this long, damn. Now what we can do, we've got minus 4x minus 2 into 0, which is minus 4x. Is that the answer? Yes, because if you do what we call the product rule here, is it the power rule? Yes, the power rule. You multiply here, get minus 4x. This one is 0. So it's definitely correct. So this one is a matter of just doing this thing as often as you need to. It's usually not so difficult. Okay guys, let us move on. What is the next one? So here we're just going to use the rules. So here we're told to find the derivative dy over dx if y is equal to that. Easy. We need to sort our y first. Okay. So we know y is equal to 7x to the exponent 4. I'm going to be doing this back and forth, plus 2x squared over the square root of what? Of x. So we need to make this thing to be linear first. We can't have fractions. So this is the same as 7x to the 4th plus, now when we change this thing, it's going to be effectively 2x squared times x to the minus 1. Is it not? No, minus a half, sorry. Because this is x to the half, so this is x to the minus half. And then we work it out a little bit more, plus 2x. Now remember, x, same base, so we can deal with the exponents when we're doing a product. So 2 minus a half is 1.5, right? Yeah, boo. So this is 2 to the exponent 3 over 2. Now that is done, so we can say this implies that dy over dx is going to be multiplied in front. 4 by 7 is 28 x cubed plus, now when we multiply there by 2 we get 3x, then we subtract 1, so we get a half. Alright, so here please don't try to simplify this any further. Please don't simplify it any further, unless they state you want to change this into the square root. It's not a big deal, just leave it here. Simple. You get a mark for this too. And then I think we get a mark for this one. Yeah, that's it. That's it. That's how you get those marks. So 7.2.2. What are we supposed to do now? Oh, we've got that one. Well. So we can deal with it this way. So what do we have on top is 3x squared minus 7x. That was minus what? 6 all over x. Now when you deal with this one, you just continue working things out. So what can you do here? Well, the simplest, because we won't be able to find a common factor, just divide each term by x. So this will effectively be 3x minus 7 minus 6 times x to the minus 1, is it not? Yes. So I'm moving a bit quicker, but anyway, what you would do here, this would essentially be 6 over x, right? Just for the sake of dragging a little bit. So this is 3x minus 7 minus, now when you change this, it's going to be 6x to the minus 1. Now you understand, right? Which this whole thing is going to be equal to. Now we take the derivative, it's going to be 3 plus 6x to the minus 2. That's it, because the derivative of a constant is 0. Done. So there you are. So how many marks were you supposed to score on this one? 4 marks. Wow, that's strange. That is super strange. Where am I now? Yeah. So I guess you're getting a mark for this and that. Ne? Yeah. And then I think this step is important. So because you've done 2 things here, you've divided and did things here, maybe you can say 2 marks here. It's fine. So that's it. Alright guys, yeah, the guy is a bit tired. I wanted to do 2 hours only, but now I ended up going beyond. Let's do question 10. Again, I've done calculus and the applications on that other video of functions. So please, if you're interested in more, go and look for it. It's gonna be on the description box, the link that is. Question 10 is probabilities. Now this is the section that gives headaches, you know. It's very easy questions, but they can be annoying. But let's go for it. So 10.1. We're told A and B are 2 independent events. So once you are told this, what does that mean? It means the probability of A and P, we're using the product rule, is going to be PA multiplied by P of B. So remember those things, they have what you need, such that the probability of event A is 0,2 and probability of not. So once they use not B, that means you're going to have to use the complement. Just a moment. Okay guys, so that means we're going to use complementary events here. Okay, that is some of the clues that you can gather, but I mean these are straightforward questions essentially. So it says determine the probability of B. Obviously it is, we were given its complement, so we can work it out. So we're going to have 10.1.1. We know that the probability of B is going to be 1 minus the probability of not B, okay? Because they are complements of one another. So it's 1 minus 0, comma, what is that? 4, 5. And then we're going to have 1 minus 0, comma, 4, 5. So this is 0, comma, 5, 5. Okay, easy. Easy stuff. So this one is a straightforward question, so that's why it's 1 mark. Nothing busy there. So let's do 10.1.2. It says the PA or B. So you can already see here, this uses the addition rule. Okay. Hey, these people must stop making noise now. Hey, when Skelam phone like PA or B is always going to be PA plus PB minus the product, which is PA and B, right? That is the addition rule. So we were told PA 0, 2 plus PB we determined is 0, 55. But because A and B are independent events, we know that the product of the probabilities will give us that instance where they occur together. Easy, ne? Easy. Just put it in the calculator. 0, 2 plus 0, 55 minus 0, 2 times 0, 55. So I'm getting a 0, 64. Sorry, that's the answer. Great. Nice. Easy stuff. I mean, this one was not too complicated. We are getting 3 marks for this. This was a calculation on its own, and then general substitution, and then the final answer, okay? I kind of complexed things, but you can split them into halves and stuff, because I mean, this is fairly easy, okay? So let's see, do we have space here? 10.2. Now we're told Asanda travels to school on her bike and taxi. Okay, she chooses which one. Now the probability that she travels by taxi is X. So this means the probability of using the taxi is X. And then we are told that if she uses her bike, the probability that she will be late for school is 2/5. Okay, so that is the story. And if she uses the taxi, the probability that she will be late is 1/2. Okay, not a problem. The question says now determine the value of X if the probability that Asanda is not late is 8/15. So this question, you can already tell that this is not an easy question. There's always a question like this, a bit of a higher order type of question in the probabilities, but it's not high order because it's too difficult. It is of a high order because it demands a bit more attention. Here you can use any of the tools you know, from Venn diagrams to tree diagrams, but tree diagrams are the safest and usually the quickest and essentially the easiest. So let's do a tree diagram here. This one will help us. So there is Asanda. She can go to school by taxi, so we can call it T. She can use her bike, which we can call it B. Okay, great. Now, whichever she uses, she can either arrive early or she can arrive late. Same would happen here. She can arrive early or she can arrive late. Okay, so that is the story that we've got here. So now what are the values? We were told that the probability that she travels by taxi is x. Now remember, when we add these two probabilities, they should give us 1. So this is basically 1 minus x. Great. That is the most important piece of information. And then the next piece of information is that the probability that she uses a taxi. Hey, these people must stop, man. We were told that the probability that she uses her bike and be late for school is 2/3. So she uses a bike and she's late. So this is 2/3. Okay. Again, for her to be early, those two should add up to 1 as well. So 1 minus 2/3 is 1/3, isn't it? Yeah. Sorry. Let me check again. No, that's 2/5. Yeah, when? So this is 2/5, okay? So this means for her to be early, it's going to be the complement of that, which is going to be 3/5, okay? Great. Because these are complementary events. It's either you're late or early, okay? Now let's look at this one. We were told that the probability that she'll be late if she travels by taxi is 1/2. Okay? Then it means it's always going to be another 1/2 for her to be early, right? Because these two should add up to 1 because they are complements of one another. Nice. So now that our tree diagram is sorted, what do we want? We are told the probability that this lady is not late, meaning when she's not late, what's happening? It's this arm. It's either this arm that arm is for early, meaning not late. If she's not late, she's early. Or it is this arm. Okay? So those are the arms to consider for her not to be late. Okay, and then we're told that that probability is 8/15. So it's fine. So they are telling us that the probability of T and E, and remember that, okay, maybe let's do this one, and how do I write this one? Because it's either this or that, is it not? Am I right? Yeah, it's either this or this one. It's going to be her traveling by bike and being early as well. Should give us that 8/15. Okay. So it should give us that 8/15. So they're giving us an equation, basically. This implies, now what is the probability of her using a taxi and being early? It is basically 1/2 of x, because you just multiply. You see, up the arms or up the branches you multiply, down the branches you add, okay? That's as simple as that. Now that is going to be 1/2 because it's going to be x multiplied by that 1/2, or is translated to a plus in maths, all right? This probability is basically 1 minus x into 3/5. We can just write it here. This is equal to 88 over 15. Great. So now our work is a bit easier. So this is basically a half of x plus this is 3 over 5 minus 3 over 5x equals 8 over 15. Okay, we can just try and create some working space right here. Yeah, that thing is super slanted. Still slanted. I went some shinies. Damn it. It's slanted. Hi bo. Eban. Kumpatlang khanti. O tshwanetse re ke etse jwang jwale ke lle. Hai. Isa kekele ne. Hai, ngiyeka ngokuyanqela. Now what we do here, we collect like terms. This one we transpose to the other side, we sort these ones out. So let's see, 1 over 2 minus 3 over 5. Obviously it's going to be a negative, ne? So we're getting here 1 over 10x, sorry, minus 1 over 10x is equal to, then we take this one, 8 over 15, we're going to subtract the 3 over 5. So you've got calculators, so this is 1 over 15, minus 1 over 15. And therefore, you know that you divide by minus 1 over 10. Your final answer, so it gives us a 3 over 2. So x, wait, minus 1 over 15 divide by minus 1 over 10. It's 2 over 3. I don't know why I always invert this thing. It's 2 over 3. So you see, sometimes when you know what to do, your overexcitement can actually sabotage you. It can sabotage you by forcing you into a corner some way. All right? So that's it. Again, here, there's nothing much you can do. Just make sure everything is calculated properly. The steps are followed properly to the answer. That's usually how it goes. So you're getting 4 marks here. So for me, the first 2 marks is these 2 probabilities. This is what matters. And then the answer matters. And here we can just say the general substitution. So that's how you get your 4 marks. Nice and easy. Nice and easy. Sorry for that. I'm getting a bit throaty. Just a moment. All right, so question 11. So again, you know that one of the 2 is the fundamental counting principle, and the other one is just probabilities in general. So you'll always get a taste of the 2. Now we're told in a certain province, vehicle number plate codes have the following format: AAA dash 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 or hash hash hash. So the 3 letters followed by 3 digits, where this represents a letter of the alphabet and the hash tag represents the digits from 0 to 9. Okay, now for each number plate code that is assigned to a vehicle, the following conditions must be met. All letters except ego. Okay, if we cut ego out, so we've got 26 letters minus 3, which leaves us 23. Ne? So now what do? No number plate code starts with a vowel. So how many vowels have we left? We've lost 2. So there are 5, right? They are 5. Hayibo. Okay guys, so I'm getting distracted a bit. So let us move on. So now we're told here no number plate can start with a vowel. So how many vowels have we left? Remember there's 5 of them. Minus 2. So we have 3 left. Okay? So that is the story. That's the story. So now it says all digits can be used. And each digit can be repeated. Right. So now that we understand what is going on, we can start working. It says now how many vehicles can be assigned a number plate according to this. So fine. So we've got 11.1. We've got 11.1.1. No. So it's just 11.1. Okay. So we know that this represents letters, right? Sorry. So there we are. So this is letters, right? So that is letters right there. Great. And then we're going to have digits. There are 3 as well. Great. So of the letters, remember we cannot start with the vowels. So that means here we're going to subtract 3 for the beginning. So the first ones, it's of the 20 letters that we have left. But thereafter, remember of the 20 we've chosen 1, so we have 19 left. Then we add our vowels back. So it becomes 22. 19 plus 3 is 22, yes. And then we've got 22 there. And then once we pick 1, we've got 21. Okay? So that's the story. Now let's look at the digits. They are 10. So we can repeat. So technically here there are no limits. So all we do, we multiply these things. So let's see. So this is going to be 20 times 22 times 21 times 10 times 10 times 10. So I'm getting here 9240000. Okay. Well, you can say 9,240,000. Sounds like correct that way. Yeah. So let's see how many. 1, 2, 3, 4, 5, 6, 7. Yeah. If there's 7 letters, it's a million. Well, 7 digits, it's a million. So it's 9,240,000. Yeah. Yeah, it's 9 gorillas. 240 squaddles. Great. So that is the cars that can get this thing. So this one is an easy one. 3 marks. So I'm sure it's a mark for that, and for the answer. Ne? Yeah. 11.2. Now we're told to calculate the probability that a number plate code chosen from the number plate in question 1.11.1 at random contains only 1 vowel and ends with an even digit. So this question is a naughty one. It's a naughty one. It's always there. Okay? This question is always there, so please guys, learn the trick. So now what do we know? We know that we have these little letters here, 2, 3. Then we're going to have our 3 digits. Right. Of the letters, what do we know? We do not start with a vowel. So there's 20 options basically for the start here. And then, now we are saying technically, we only want one vowel. Okay? So the problem here is that there's 2 spaces here now that, you see this thing here can come up in 2 ways. All right? So that is something you need to know. So we know that if we choose that the vowels are going to be here, how many do we have? They were only 3. Okay? But we're only going to put 1. Once we put 1 there, what happened? We're going to have only 19 here left, isn't it? Because from the 20 letters, we took 1 and put it down on the first position. There'll only be 19 left for the last position, because the vowels are just throwing any one of the 3, but just 1. Okay? Great. But remember, this thing can happen in 2 factorial ways, right? Because we can interchange, put 19 there and put the 3 there. So it goes in 2 factorial ways, if you think about it. The start is fixed. Okay? But this one can interchange. So this is going to be 2 factorial. Because you can either put it in 2 ways. But this one, the digits, they just don't change. There's 10, 10, because we can repeat. But for the last one, the even terms is 0, is a 2, is a 4, is a 6, is an 8. So they are 5. Because we're told the end should be an even number. So it can be 0, it can be 2, it can be whatever. So this one is pretty straightforward because this is fixed as well. So we are happy. So the trick is understanding the fact that this thing here can happen in 2 factorial ways. This one. All right. Great stuff. So this implies that we're going to have here 20 times 3 times 19 times 2. Okay? Factorial. Because, 2 factorial is just 2 times 1, which is just 2. Okay? So we have to multiply this by 2 because of this situation. And then we're going to multiply this by 10, by 10, by 5. Okay? So that's it. That's it. So this is going to be 20. Yeah. Remember the factorial goes with these 2 guys. 10 cent not 10 jengo. Palazom kalamko. So remember the factorial is for this block right here. This block is going to be multiplied by 2 factorial. Maybe let's do it this way. Because there's 2 factorial ways we can do this little block right here. So please guys, that is the one part to make sure you get right. So 20 into 3 times 19 times 2, because 2 factorial is just 2. Okay, this one we close. And then we multiply this by 100 for 10 times 10. Then we multiply it by 5. So what we are getting is 1, 1, 4, 0, 0, 0, 0. Okay? So again, 1, 2, 3, 4, 5, 6, 7. So this is 1,140,000. Okay, so remember, these are the plates that we can get. These are the plates or number plates that we can get that fit this description. That at random, we want it to contain only one vowel and it must end with an even digit. Okay, so we then say, oh, right, okay, all right. So what is the story now? We can say the probability of the event. We don't care what that event is. It's going to be the number of those events over the sample, right? Now the number is 114000, 1,140 scored. Divide by the total was 9,240,000. Yeah. So this question is always a naughty one. 9,240 scored. It's a nasty one. So this is 19 over 154. Which, if you like me, I prefer to just leave things as fractions. No one forces you, but if you want, you can do this one to 2 decimal places. It's going to be 0.12, you know. So you can choose to end here, but nobody will punish you if you end there. Okay. So that is the story right there. That is the story right there, because these two positions, remember these two positions, the key factor is that these two positions were not fixed per se. That's why we can do them in 2 factorial ways. So this explains this 2 factorial. Don't get lost, okay? Don't get lost. It's a very nice question. So it's one of those nasty questions. Here, it's either you get it right or you get it wrong, because I can tell you, by the time you get to this question, it's already too late. So for you to focus, it's almost impossible. So if you don't know what to do, you are essentially a dead person. Okay, let's see where are the 5 marks. Well. This thing is a mark. This thing is a mark for the digits. And this thing is a mark for that answer because it's important. And then substitution into a correct formula and the final answer. Of course, you can mark it here, you can mark it here. It's up to you. So guys, that's the end of my video. So I hope you liked it. I hope you've learned something. If you spot any mistakes, was there any more? Wow, how did I end up with so much pages after? Anyway, so if you guys liked the video, well, it's good. And if you've learned something, all good, because it will help you to get ready for those exams. Otherwise, goodbye for now. See you next time.